Hello there, and welcome to the Snoozy Scientist. I'm so glad you've chosen to spend a little piece of your evening, your morning, or perhaps somewhere peacefully in between, winding down with me. Tonight's story is all about something we see every day, something we drink, swim in, and often forget to question: water. We've grown so familiar with it that we almost stop noticing it. But have you ever paused to wonder, how did all this water get here in the first place? You see, Earth wasn't always blue. It didn't begin with oceans or rain, or even mist. It began as fire. Long ago, it was just a molten sphere, a world of lava and lightning, glowing red in the dark. So how did that burning rock become the blue marble we now call home? That's the quiet mystery we're drifting into tonight. From the icy edges of space to the boiling heart of the Earth, we'll follow the strange and beautiful journey of how water arrived, stayed, and changed everything. But before we begin, I'd love to know, where in the world are you listening from, and what time is it there right now? Drop a little note in the comments. It always brings me joy to see how far these gentle science stories manage to ripple out across the globe. And while you're there, if this video helps you slow down, unwind, or maybe just adds a little calm curiosity to your day, I'd be honored if you'd give it a like and subscribe to the channel. Your support helps me keep creating these calming, curiosity-filled explorations just for you. Now get cozy, maybe pull the covers a little tighter, take a slow sip of something warm, and let your thoughts drift softly, because tonight we're about to follow a single drop of water all the way back to the beginning. Long before oceans kissed the shores of Earth, before clouds drifted lazily across blue skies, and long before the idea of a planet even existed, there was silence. No rivers, no lakes, no seas, just a dark and endless expanse stretching in every direction. It was not cold the way winter feels cold, but cold in a way that went on forever, a kind of stillness where nothing yet stirred, a quiet so deep it had no beginning, no end, only space. In this vast emptiness, there were no droplets, no storms, and no signs of life, just the tiniest particles, invisible and weightless, drifting gently in the black. Among them was hydrogen, the simplest, lightest, and oldest element in the universe. Born in the first few minutes after the Big Bang, hydrogen had been around longer than anything else we know. You could say it was the first building block, the first brushstroke on the blank canvas of creation. Imagine these tiny hydrogen atoms, each one unimaginably small, yet filling the darkness with quiet potential. They floated alone for a very long time, gathering only slowly into clouds like cosmic mist. And in time, under the pull of gravity, some of those clouds began to swirl, compress, and collapse. Slowly, almost hesitantly, stars were born. Inside these stars, a new kind of magic began. The pressure at the center of each star was so intense, so concentrated, that it forced hydrogen atoms to fuse together. This process, called nuclear fusion, created something new: helium at first, and eventually heavier elements like carbon and oxygen. Oxygen, that's the second ingredient we need for water, but we're not there yet. When the biggest of these stars reached the end of their lives, they didn't go quietly. They exploded violently, beautifully, in events called supernovas. These explosions scattered the oxygen they had made across the universe, flinging it into the cold dark like a burst of glowing confetti. Now, drifting through space, we had hydrogen from the beginning and oxygen from the stars. Still separate, still waiting. It would take time for them to find each other. Between the stars, in the thin wisps of dust and gas we call interstellar clouds, the two began to meet. Not quickly, not loudly, just here and there, a molecule would form, two hydrogen atoms and one oxygen atom, bonding together to make something new, H2O, water. But at this point, it wasn't the flowing kind you might pour into a glass. These molecules were locked away in ice, clinging to tiny grains of dust floating between the stars. Think of them as the universe's first snowflakes, tiny, frozen, and impossibly far from any planet. These icy particles began to stick together, ever so slowly. Some gathered into clumps, some clumps became comets, some comets became part of something bigger. That's the origin of water, not from a stream, not from a storm, but from silence, from hydrogen forged in the beginning and oxygen forged in fire, before water danced across the earth, before it filled oceans or fell as rain. It drifted through the emptiness, patient and quiet, and somewhere out there, in the cold between the stars, the first drops were waiting to fall. To understand how water came to be, we need to meet its parts. We've already met hydrogen. It is the most abundant element in the universe. Simple, ancient, light enough to float through space, untouched by time. Hydrogen was there from the beginning, from just moments after the Big Bang. But water needs something more. It needs a partner, and that partner is oxygen. Oxygen didn't come easily. In the early universe, there was no oxygen at all, just hydrogen, helium, and darkness. But within that darkness, something powerful was waking up. Stars. Stars are not quiet things. They shine, they burn, they live with enormous force. Inside them, something extraordinary happens. Their gravity squeezes the material at their core so tightly it creates a kind of pressure we can barely imagine. This pressure makes hydrogen atoms fuse together, forming helium and releasing light and heat along the way. But stars do not stop at helium. As they grow older, especially the giant ones, they begin to fuse helium into even heavier elements. Carbon comes next, then neon, then magnesium, and then finally oxygen. It takes a lot of energy to make oxygen. Only the biggest, most massive stars are strong enough to do it. Inside their blazing cores, these stars act like cosmic forges, creating the ingredients of life from the simplest particles in the universe. Oxygen forms quietly inside these stars, trapped for a time in their burning bellies. And then eventually the star begins to run out of fuel. It can no longer hold itself together. Gravity pulls inward, the outer layers collapse, and the star explodes. A supernova. A single supernova is brighter than an entire galaxy, if only for a moment. But the true beauty of a supernova isn't in its light, it's in what it leaves behind. All those elements, carbon, iron, silicon, and yes, oxygen, are thrown out into space, spread wide like seeds from a bursting flower. Imagine that, a star far bigger than our sun, living its life quietly in a distant corner of the universe, spending millions of years building oxygen deep within itself, only to scatter it across the cosmos in one final spectacular act. This is how oxygen arrived. Every molecule of oxygen you breathe, every atom of oxygen in the oceans, in your blood, in the air outside your window, it was created in the heart of a dying star. That's the missing half of water's story. We had hydrogen from the very beginning. Now we had oxygen too, floating through space, drifting on winds of stardust. The two elements wandered until they found each other, but we're not quite there yet. For now, we are left with this thought, that the oxygen in every drop of water you've ever touched once lived inside the furnace of a star. Water is more than a liquid. It's a meeting of two pieces of the universe's past. One ancient and quiet, one fiery and fierce. Together, they created something soft, something essential, something beautiful. And so the story of water moved forward, carried by stars, waiting for a place to fall. By now, the two essential ingredients for water were floating through space. Hydrogen, the firstborn of the universe, had been there from the beginning, silent, weightless, and endless. Oxygen, the younger element, had only recently arrived, scattered outward in the wake of exploding stars. Two lonely travelers in the dark, drifting through the emptiness between galaxies. It would take time, but eventually they would meet. Not in oceans or rivers, not in clouds or rain, but in deep space, where temperatures drop so low that time itself seems to move slower. In this cold, quiet place, something beautiful began to happen. Scattered between the stars is more than just emptiness. There are vast clouds of dust and gas stretching light years across. These clouds are thin, so thin that if you scooped up a handful, you might only find a few molecules, but they are full of possibility. Tiny grains of dust float through these clouds. They are smaller than a speck of sand, made of silicates, carbon, and sometimes ice. They're not much to look at, but they play a starring role in the story of water. You see, space is not a place where atoms bump into each other very often. It's too empty, too slow, but when a free-floating hydrogen atom drifts close to one of these dust grains, it might stick, just for a moment, and that moment is enough. If another hydrogen atom follows, they might bond, and if an oxygen atom happens to wander close, it may join in. Suddenly, there is something new. H2O, a water molecule. It doesn't float away. Not yet. Instead, it stays frozen onto the surface of the dust grain. The universe, after all, is unimaginably cold in these places, just a few degrees above absolute zero. Water cannot flow here. It cannot drip or ripple or steam. It exists only as ice, hard, crystalline, and still. This is how the first water in the universe formed. Not in lakes or streams, not even in planets, but as thin layers of frost building up on the surfaces of cosmic dust grains, floating in the quiet spaces between stars. Over time, these ice-coated particles begin to gather. Slowly, patiently, gravity tugs gently, pulling them toward one another. Clumps form. Some of those clumps become icy rocks. Some of those icy rocks grow into comets. Others join together into asteroids. A few even find their way into the swirling disks that will one day become planets. The water stays with them, locked in the ice. These aren't just rocks or dirty snowballs. They're messengers. Each one carries frozen water that was born in the dark long before Earth existed. They are delivery vessels waiting for a destination. It's amazing to think that something so soft, so familiar, began in a place so cold and distant that the water in your cup, your breath, your blood, may have first come together on a tiny dust grain orbiting nothing at all, just drifting. Of course, not all of it made it to Earth. Some stayed frozen in distant comets. Some was swept up by other worlds. Some was lost entirely, broken apart by radiation or scattered by collisions. But some survived, and that's where the story begins to shift. These icy grains, these ancient crumbs of frozen space, began falling inward toward a young, violent, newly formed star. That star was our sun, and swirling around it was dust, gas, rock, and possibility. In that spinning cloud, a planet was taking shape. Hot, molten, dangerous. But nearby, hidden among the rubble, were these tiny, frozen time capsules. Water was coming to Earth, but we're not quite there yet. For now, just pause and let this image linger. A tiny fleck of dust floating in the darkness, slowly gathering a layer of frozen water over millions of years. No sound, no rush, just atoms meeting quietly in the cold. This is where water began, not in clouds but in shadows, not in oceans but in ice, not on Earth but between the stars. Some stories move quickly, they rush forward, filled with noise and motion, but the story of water, real, ancient water, begins in quiet. It starts with something small, a speck of dust just floating, alone in the dark. It drifts for a long time, years, centuries, perhaps even millions of years. But time works differently out here. For us, in the silent spaces between stars, those tiny grains we talked about, the ones coated in frost, holding the very first water molecules, begin to bump into other grains, slowly, softly, like snowflakes sticking together in the dark. These frozen bits of dust don't stay small forever. Gravity is always working, always tugging. And so, over time, what was once a fleck becomes a cluster, and that cluster becomes a pebble, and the pebble becomes a rock, until one day, the rock is something much more, a traveler. Some of these icy travelers become comets, great, wandering snowballs of space made of ice, rock, and dust. Others become asteroids, rockier and denser, but still holding tiny pockets of frozen water hidden deep inside. And a few break apart into smaller fragments we call meteorites, pieces of ancient material that sometimes find their way into a planet's sky. They are the couriers of the cosmos. They do not hurry, they follow long, slow orbits around stars. Many were born in the cold outer reaches of the solar system, far beyond the planets, places where sunlight barely touches and temperatures are too low for liquid to survive. But even from that great distance, they matter, because these icy travelers are not just random space debris, they are carriers of water, ancient water, water that formed long before our planet did. Water that remembers a time before Earth had oceans, before Earth had clouds, before Earth had anything. Comets, in particular, are some of the most beautiful objects in the sky. When they pass close to the sun, their icy surfaces begin to vaporize, and as the ice turns to gas, it creates a glowing tail that can stretch across the heavens. It's breathtaking, but that shining trail is also a reminder it is made of dust and vapor, of frozen water returning to space. Most of the time, these comets stay far away. They loop out into the dark, orbiting silently, but sometimes their paths bring them closer, closer to the warm inner part of a solar system, closer to a young, forming Earth. And when that happens, something extraordinary begins. Icy asteroids and comets, still holding the water they formed billions of years ago, start falling not all at once, not in a single dramatic impact, but over time, a steady rain of rocky frozen messengers. Earth, in those early days, was a violent place. It was hot, molten, constantly changing, but it was also in the middle of a storm, a bombardment of cosmic visitors crashing down from above. Scientists call this period the Late Heavy Bombardment. It happened about 4 billion years ago. And while it sounds destructive, and it may have also delivered one of Earth's greatest gifts, water. Each impact brought more ice, more dust, more ancient molecules from the edge of space. And as the planet cooled, that water began to stay, to gather, to shape. You can think of these comets and asteroids as the universe's delivery service. Their packages were small, but the message they carried was powerful. This planet, this hot newborn world, was ready for water. Not every scientist agrees on how much of Earth's water came this way. Some believe most of it arrived from below, through volcanic steam. Others believe comets and asteroids were the true source, and perhaps the answer is both. But no matter the balance, one thing is clear: these icy travelers played a part. Every drop that fell from the sky, every molecule tucked into a meteorite, every bit of frost clinging to an asteroid, each one helped build the world we know now. The oceans, the lakes, the rivers, they all began with travelers, small, frozen, determined. And so, as we take a sip of water, or watch the rain fall outside, or see a comet streak across the night sky, we are touching something very old, something that started far from here, something that crossed the stars to find its way home. Water did not just appear, it arrived, carried by cosmic hands, wrapped in ice, delivered piece by piece by silent visitors from the edge of everything. If we could go back farther than memory, farther than time itself, we would find Earth not as we know it, but as something unrecognizable. No blue skies, no oceans, no clouds, just heat, roaring, seething heat. The early Earth was not a gentle place. It began as a molten ball, born from the same swirling cloud of dust and gas that had given rise to the sun. Everything was moving, everything was crashing, everything was hot. So hot, in fact, that even rock was a liquid. Imagine looking down on this newborn world. You wouldn't see green forests or winding rivers. You'd see rivers of lava, vast oceans of magma. You'd see lightning tearing across thick, poisonous skies. You'd see volcanoes, thousands of them spitting fire into the air like angry giants. There was no calm, no quiet, just the endless sound of things forming and breaking and forming again. The crust of the earth was thin, fragile, and constantly shifting. It cracked and buckled under the pressure of its own heat. Beneath that crust, the mantle churned like a boiling stew. Nothing was still, everything was in motion, and above this wild surface hung an atmosphere thick with gases, carbon dioxide, methane, ammonia, and sulfur. There was no oxygen yet, no breeze, just dense choking air wrapped tight around a planet, still figuring out what it wanted to be. This was the stage for Earth's first encounter with water, and it began not from the sky, but from deep inside. You see, the rocks and minerals forming Earth's interior weren't entirely dry. They contained tiny amounts of water, trapped from the beginning. As the planet's surface cracked and volcanoes erupted, that water began to escape, carried upward as vapor, released through steam. Volcanoes became Earth's first fountains. With each eruption, more gases spilled into the atmosphere, and among those gases was water vapor, hot, thick, and invisible. At first, the Earth was far too warm for it to do anything but hang there, suspended in the heavy air. But over time, something began to shift. The planet was cooling. Not fast, not all at once, but slowly as the bombardments lessened and the surface began to settle. The temperature dropped, crust thickened, lava hardened, the atmosphere began to thin, and the water vapor started to condense. Tiny droplets formed in the air. Clouds began to take shape, dark, dense, and full. And then for the first time, it rained. Not a drizzle, not a passing shower, but a downpour unlike anything we can imagine. It rained for centuries, maybe even longer. The sky opened and water began to fall. It hit hot rock and hissed into steam. It filled low places and sizzled back into the air. But it kept coming, drop after drop, storm after storm. The entire planet became a rinse cycle. That rain was the first gift of Earth's interior, a release of vapor transformed by time and temperature into the very beginnings of the oceans. And though the planet was still violent, still burning, water began to claim its place. Some of it stayed in steam, circling the globe in thick fog. Some of it soaked into the cooling crust, finding cracks and crevices to hide in, but a little of it, just enough, began to gather. In pools, in puddles, in places where the land sagged low. And these shallow basins became the quiet seeds of something much bigger. The oceans were not yet born, but they were coming. It's easy to think of water arriving from the sky, but the truth is, Earth was already carrying it, like a secret waiting to be told, like a breath waiting to be exhaled. The fire of the planet made way for its steam, and that steam became the first rains, and those rains began to cool the chaos. If you stood on the surface of early Earth, though you wouldn't survive for long, you'd feel the heat rising from below and the rain falling from above. You'd see lightning tearing across clouds. You'd see lava bubbling beside newborn streams. You'd witness a world at war with itself. And you'd also see something else. You'd see balance beginning to form. It was not peaceful, not yet, but it was the start. The fire gave way to water, the burning began to cool, and Earth, our Earth, began to become a place where oceans could exist, where life could begin. Sometimes the quietest origins begin with fire. When we think of water, we often imagine rain falling from the sky or waves gently brushing the shore. But deep inside the earth, far below the crust, below the roots of mountains, below even the deepest ocean trenches, something unexpected is hiding. Water, not in pools, not in rivers, but in minerals, locked inside rocks, trapped in crystals, hidden away in places no sunlight has ever reached. From the very beginning, Earth's interior has carried water like a secret, and as the young planet cooled and shifted, it began to release that secret, one breath at a time. The breath came through volcanoes. You might not think of volcanoes as sources of water. They feel more like destroyers, hot, explosive, wild. But these fiery vents also tell a quieter story, because every time a volcano erupts, it is not just rock and fire that escapes, it is also gas, a lot of gas. And among those gases, there is steam. Volcanoes are like chimneys, connecting Earth's deep interior with its surface. When magma rises, it carries water with it, water that has been trapped for millions of years. As the magma reaches the surface, the pressure drops and the water turns to vapor. The result is an eruption, a roar of ash and fire, yes, but also a soft, continuous breath of steam rising into the air. Imagine standing near one of these early volcanoes. The sky above is dark with smoke. The ground rumbles beneath your feet. From the crater, a plume of gas curls upward, spiraling into the sky. That plume is not just smoke, it is moisture, steam, water returning to the air after its long journey through the Earth's belly. In the early days of our planet, there were thousands of volcanoes erupting day after day, year after year, century after century, and with every eruption, more steam escaped. The air began to fill with it, slowly, patiently. It did not rain right away. The atmosphere was still far too hot. But over time, as the Earth cooled, that steam began to condense, clouds formed, and from those clouds came the first drops of rain. This is what scientists call the outgassing theory, the idea that Earth's original water came from within, that volcanoes breathed it out, that the seas began as steam, it is a beautiful possibility, because it means the oceans weren't just delivered from space, they also rose from the Earth itself, born of pressure, carried upward through rock, released into the sky, and then sent gently back down as rain. It is humbling to imagine that the water in your tea, your bath, your blood might once have steamed from the mouth of an ancient volcano. And the numbers are surprisingly large. Even today, volcanic eruptions release water vapor into the air. Some studies suggest that up to 70% of the gas coming out of a volcano is water. Multiply that by millions of eruptions over billions of years, and you begin to see how much moisture could have built up. Of course, the story is still unfolding. Scientists continue to debate exactly how much of Earth's water came from volcanoes and how much came from icy visitors, comets, asteroids, and meteorites. But perhaps the truth is somewhere in the middle, a collaboration between the sky and the ground, between outer space and inner Earth. And either way, the volcanoes played their part. They breathed, they boiled, they broke the surface, and with every breath, they gave Earth just a little more of what it needed to become blue. It is strange to think of something so violent giving rise to something so calm, but that is the way of our planet. Fire leads to steam, steam leads to clouds, and clouds bring rain. So the next time you watch mist rising from your kettle or fog creeping over the hills, remember, Earth has been breathing steam for billions of years. And with every breath, it was becoming something new. Before the oceans formed, before rivers carved valleys, or clouds floated across the sky, Earth's surface was still trying to catch its breath. The fires were beginning to settle, the crust was hardening, but something quiet, almost invisible, was rising. Steam. Not from clouds, not from rain, but from deep inside the planet itself. You see, Earth has always carried water, even in its earliest days when everything was molten and wild. Water was there, locked deep in minerals and magma, trapped in the mantle, waiting. But it could not stay hidden forever. As the planet began to cool, it also began to crack. The crust was thin, broken in places, and filled with heat beneath. And through these cracks came pressure, and through the pressure came release. Volcanoes erupted, geysers hissed, fissures opened, and from them, water vapor began to rise. This idea that Earth's water came from within is known as the theory of outgassing. It is simple and yet deeply powerful. It says that the oceans we see today may have started not with a splash, but with a sigh, a slow release, a breath of steam, a whisper from the deep. Imagine a time when the air was thick with volcanic gas, carbon dioxide, methane, ammonia, and water vapor, lots of it. Each time the Earth opened up, more steam escaped, rising upward, collecting in the heavy atmosphere. For millions of years, this went on, a soft exhale from the mantle, over and over again. But steam cannot remain steam forever. The planet was still young, but it was changing. Heat was escaping into space, the crust was thickening, and at last the air began to cool. Slowly, the water vapor in the sky condensed into tiny droplets. Clouds began to form, dark and heavy and full. And then it rained. It did not drizzle. It poured for days, for centuries, perhaps for millions of years. This was not the kind of rain we know now. There were no birds in the sky, no trees to catch the drops, no soil to soak it in. The rain fell on bare rock, on bubbling lava, on fields of fire. It fell and sizzled and steamed, but still, it fell. Every drop that made it to the ground began to pool. In the lowest places, water gathered. It trickled down slopes. It filled cracks and crevices, and as more steam condensed, and more clouds formed, and more rain came, those little pools became something else. They became oceans. No, not all at once, not in a moment, but slowly, patiently, and powerfully, drop by drop. This is the magic of outgassing, the idea that Earth created its own water supply, using nothing more than heat, pressure, and time, that the seas weren't delivered, but rather drawn out from within. Even today, the Earth continues to outgas. Modern volcanoes still release water vapor, geysers still bubble and breathe. The process never truly stopped, it only slowed. Some scientists believe outgassing may have created nearly half of all the water on Earth. Others think it contributed even more. The truth is, we may never know exactly how much came from below and how much fell from the sky in the form of icy comets and asteroids. But what we do know is this, without outgassing, there would be no clouds, no rain, no oceans. Without outgassing, Earth would be dry. There is something deeply poetic about this, that a world built in fire found a way to cool itself, that from pressure and flame came mist and waves, that from the inside out, the Earth shaped its own story. A story written in vapor, told through rain, remembered by the sea. So the next time you hear a soft rain tapping at your window, you are hearing something very old, something ancient, something born deep below your feet and carried all the way up into the sky. You are hearing the Earth breathe. For a while, the theory of outgassing painted a beautiful picture, a planet wrapped in its own breath, steam rising from deep below, rain falling, oceans forming. It made sense. It felt whole. It explained how fire gave way to water, how a hot, dry planet became the watery world we now know. But science has a quiet habit. It keeps asking questions. And over time, those questions uncovered something puzzling, something that didn't quite add up. You see, when scientists tried to measure how much water Earth's mantle could have released through volcanic outgassing, the numbers came up short, not by a little, by a lot. The Earth's crust is soaked with evidence of water. The oceans alone hold over 1 billion cubic kilometers of it. But when researchers looked deep into the planet's interior, into the rocks and minerals that should have once held that water, it seemed unlikely they ever held enough. Even if every volcano from Earth's earliest days had erupted endlessly for millions of years, even if every crack in the crust had hissed and steamed, it still probably wouldn't be enough to account for all the water we see today. The mantle had given its share. That much was clear, but the story didn't feel complete. Something was missing, and so scientists looked upward, not into the skies of Earth, but into space, into the cold, distant reaches of the solar system. They began to ask a bigger question, one that felt bold at the time. A little strange, but deeply important. What if some of Earth's water didn't come from Earth at all? It was not an idea that came easily. For centuries, people imagined the oceans as being part of the Earth from the start. But now researchers were beginning to see things differently. To imagine a planet that was once dry, hot, and very thirsty. And out there in the darkness, they found a possible answer. Comets, asteroids, meteorites, icy bodies drifting through space, carriers of ancient water formed long before Earth existed. These cosmic travelers, born in the cold, might have brought something essential to the fire. They might have brought rain. The idea was elegant. Earth, in its early years was under constant attack. The solar system was young, chaotic, and full of collisions. During a period called the Late Heavy Bombardment, asteroids and comets rained down on the inner planets, and many of them carried water. These impacts would not have been gentle. They would have scarred the Earth, shaken it, melted parts of its surface. But they also would have delivered ice, frozen molecules formed in deep space, carried on rocky shells, and scattered across the forming crust. Some of that water would have boiled away immediately, but some would have stayed, trapped in the cooling rock, seeping downward, pooling in cracks, and over time, joining the water already rising from within. It is a theory still being studied, still being refined, because the truth is, water leaves few clues. It evaporates, it moves, it flows away from the places it once touched. But hidden in the chemistry of ancient rocks and meteorites, scientists have found hints, ratios of hydrogen and deuterium, isotopic fingerprints that match not only Earth, but the cosmos. It seems more and more likely that Earth's oceans were not made from a single source, not just from volcanoes, not just from space, but from both. Steam from below, ice from above, one breath, one snowflake, one drop at a time, and together they became oceans. The problem with steam alone was never that it was wrong, only that it was incomplete. Earth's own water helped shape the seas, but it had help from stars, from comets, from the vastness beyond our sky. And that, in a way, makes the story even more beautiful. And because the water in your tea, the water in your blood, the water in the clouds above your home, it is part of two worlds. It rose from lava and it fell from the stars. A meeting of opposites, a union of fire and ice. And it made everything possible. Not all rocks are dry. Out in the cold, quiet reaches of the solar system, there are ancient travelers. Some are large, some are small. All of them are leftovers. Leftovers from a time before Earth, from the time when the planets were still forming. These rocks have wandered for billions of years, circling the sun along slow looping paths. And hidden inside some of them is water. Not water in puddles or pools, not flowing or rippling, but water bound up in stone, water tucked into the structure of minerals, frozen, silent, waiting. These are not ordinary space rocks. Scientists call them carbonaceous chondrites, a special kind of meteorite that contains a surprising ingredient, H2O. They do not look like much at first glance. Dark, heavy, often speckled, but inside they carry something remarkable. Water molecules locked in clay, traces of ice preserved since the beginning of the solar system. When scientists study these meteorites, they find something even more astonishing. The water inside them is chemically similar to the water in Earth's oceans. The ratios of hydrogen and its heavier cousin, deuterium, match almost perfectly. That tiny detail changes everything because it suggests that the water we drink, the water in our clouds and rivers, may have come from the same source as these ancient space rocks. Imagine that. A piece of stone formed in the outer solar system breaks free. It travels for eons, and one day it crosses paths with a young Earth. It falls through the atmosphere, heats up, burns, and crashes into the surface. And when it breaks apart, it leaves behind more than dust. It leaves behind water? Not much, perhaps, just a few droplets, locked in stone, but over time, rock after rock, impact after impact, those droplets add up. That is one of the quiet wonders of carbonaceous chondrites. They are tiny time capsules, carrying water from before Earth had oceans. They were built in the cold, far from the sun, and yet they helped make our planet wet. They are part of the theory of cosmic delivery, the idea that Earth's water wasn't just made here, it was brought here, piece by piece, by these rocky visitors from the dark. Asteroids like these are not rare. The asteroid belt between Mars and Jupiter is full of them. Some contain metals, others carry silicates, but the ones that matter most to this story are the ones with water. We have even seen them up close. Space missions like NASA's OISS-REx and Japan's Hayabusa 2 visited asteroids and brought samples back to Earth. And inside those samples, scientists found something familiar. Moisture? Not much, just a trace, but enough to say with confidence, these rocks, these distant wanderers, really do carry water. It is not just a theory anymore. It is evidence. Evidence that our oceans may have cosmic fingerprints, that some part of Earth's water fell from space in the form of asteroid rain, not in a single moment, but over millions of years, quietly, constantly. Every drop had a journey, and perhaps that is the most beautiful part. Because when you sip a glass of water, you are drinking history. You are tasting something that may have formed before Earth itself, something that drifted through space, something that crossed light years to find you. It came not just from volcanoes or clouds or rain, but from stone, from icy minerals locked inside ancient rock, from asteroids, from the cosmos. And it makes you wonder, what else is out there? What other worlds might be touched by water, just like ours? If these tiny rocks can carry oceans in their hearts, what might they be delivering somewhere else? But those are questions for another night. We'll uncover Prærnal or Blaj the Ridspiti, Bathors Benselv, Bullock Dong, pure sins of Nide, pure slow. For now, it is enough to know that Earth's water has a wider story, that it came not from one place, but from many, that some of it rose from the deep, and some of it fell from the stars. And in between, it became something gentle, something essential. It became home. 4 billion years ago, Earth was not yet the planet we know. It did not have peaceful blue skies. It did not have quiet forests or gentle tides. It was still young, still forming, and it was under siege. From the outer reaches of the solar system, something strange began to happen. Asteroids, comets, fragments of ice and rock. They came in waves, one after another. For millions of years, the inner planets were bombarded. A relentless rain of debris falling from space, crashing into the surface, shaping everything they touched. Scientists call this time the Late Heavy Bombardment. It sounds dramatic, and it was, but it also might have been exactly what Earth needed. Because those crashing rocks did more than scar the surface. Many of them carried water. Picture it. A hot, rocky planet, still cooling, still breathing steam. And then from above, the sky fills with fire, bright streaks of light as comets enter the atmosphere. Some burn up, some explode, others strike the ground with enormous force. Each one brings something with it. Frozen molecules, icy dust, ancient water from the coldest corners of the solar system. Most of it melts instantly, some of it boils away, but some seeps in, some stays, and drop by drop, the surface begins to change. Craters fill with water, steam rises from the impact zones, and somewhere in the low places, tiny lakes begin to form. It did not happen overnight. This wasn't a single explosion or a sudden flood. It was long, it was chaotic, and it was necessary. For millions of years, the planet was reshaped again and again. The crust cracked, mountains rose, basins formed, and all the while, asteroids and comets kept falling. It was messy, violent, and strangely beautiful. This bombardment didn't just happen to Earth. Venus, Mercury, and even the moon were hit too. If you look at the moon tonight, the scars are still there. Those craters are quiet reminders of the storm that once swept through the solar system. But Earth had something special. It had heat, it had volcanic steam, and it had the ability to hold on to water. So while other worlds remained dry and broken, Earth began to soften. With every impact, more water arrived, and the planet became wetter, bluer, closer to what we now recognize as home. The evidence for this great bombardment comes from many places. From the moon, from ancient meteorites, from the chemistry of rocks buried deep in the earth. And though the exact details are still debated, most scientists agree something dramatic happened. And whatever it was, it helped deliver the ingredients of life. Not just water, but carbon, nitrogen, organic molecules that may have come riding in on comets, tucked into tiny cracks and frozen pockets. The late heavy bombardment was more than destruction, it was delivery. And what it brought was priceless. Because without it, Earth might have remained dry. Volcanic steam alone may not have been enough. But with help from space, the pieces began to fit together. Steam from within, ice from above, and together they began to form the first true oceans. And once those oceans took shape, they stayed, they swirled, they spread, they found every valley, every crack, every place they could rest. And Earth became blue, became blue, became cold. It is strange to think that something as peaceful as water could come from such chaos, but that is how nature often works. Out of fire and stone, something soft is born. Out of collision comes creation. So when we look at the ocean now, we are seeing the result of billions of years of change. We are seeing the quiet that followed the storm. We are seeing memory held in waves. And maybe, just maybe, we are seeing the beginning of life. Because once the water was here, everything else could begin. So far, we've followed water from deep inside the earth. We've watched it rise as steam, fall as rain, and pool in the low places of a still cooling world. We've seen rocky asteroids crash through the sky, delivering droplets hidden in minerals. But now, another kind of traveler arrives. Not heavy like asteroids, not solid like meteorites. These visitors are lighter, colder, more delicate, decayed. They are comets. Comets are among the oldest objects in the solar system. They were born in the same cloud of gas and dust that gave us the sun, the planets, the moons, and all the spinning pieces in between. But unlike the rocky bodies that formed closer to the sun, comets come from the outer edges, places so cold that ice never melts. Out there, far beyond Neptune, in regions called the Kuiper Belt and the Oort Cloud, comets sleep. They are frozen time capsules, untouched by heat, unchanged for billions of years. And what are they made of? Mostly ice. Not just water ice, but also frozen gases like carbon dioxide, methane, and ammonia. Mixed in with the ice are bits of dust, rock, and organic molecules. But it's the water that makes them most interesting to our story. Because these icy bodies don't always stay in the outer dark. Sometimes something disturbs them, a passing star, a gravitational nudge, and they fall inward. They begin a long, slow journey toward the sun. As they get closer, the sunlight warms their surfaces, the ice begins to vaporize, gases escape, dust flies loose, a glowing tail forms, stretching millions of kilometers behind them. That's what we see when a comet crosses the sky. A bright head, a long trailing tail, a soft ghostly visitor. But what happens when one of those comets doesn't just pass by? What if it collides with something? What if long ago, comets struck the Earth? This is not a new idea. Scientists have wondered for decades whether comets could have contributed to Earth's oceans. After all, they are made almost entirely of frozen water. And during the late heavy bombardment, when Earth was being pummeled by space rocks, it's likely that comets were among them. The impacts would have been dramatic. A comet traveling at high speed crashes into Earth's surface. The ice vaporizes instantly, but not all of it would be lost. Some of that water would mix into the atmosphere. Some would cool and condense. Some would fall back to the surface as rain. And over time, just like the asteroids, these frozen messengers may have delivered their share of water to the growing oceans. But how do we know? To answer that, scientists look at something very small, something invisible to the eye. They study the chemical fingerprints left by water molecules, specifically the ratio between two forms of hydrogen, regular hydrogen, and a heavier version called deuterium. Earth's ocean water has a specific ratio, so scientists have compared it to the water found in different comets, and the results? Complicated. Some comets have water that matches Earth's oceans closely, others do not. Some have too much deuterium, some have too little. The pattern is not simple. It suggests that not all comets are the same, and not all of them brought water like ours. But this does not mean comets were not involved. In fact, it may point to a bigger truth, that water came from many sources, some from volcanoes, some from asteroids, some from comets, each one playing a part, each one adding its drop. The comets that did match our oceans show us that it's possible that at least some of Earth's water may have come from these icy visitors, from deep space, from beyond the planets. It's a humbling idea that the oceans lapping at our shores today may have started as frozen particles in the farthest corners of the solar system, that the rain falling on your window might include molecules that once drifted for millions of years, asleep in the dark. Comets are more than bright lights in the sky. They are storytellers, carriers of ancient memory, and in the case of Earth, they might also be givers of life. They remind us that water doesn't always rise. Sometimes it falls, and sometimes it arrives from the stars. For a moment, it seemed like we had our answer. Earth was bombarded by icy space rocks. Water seeped in from volcanoes. Comets, elegant and ghostly, crashed through our skies, perhaps leaving behind rivers and rain. Oceans, in that version of the story, were built bit by bit, a patchwork of cosmic generosity. But science, like water, flows deeper. To truly understand where Earth's water came from, we need to look closer, much closer, not with our eyes, but with instruments, with precision, with patience, because hidden inside each drop of water is a clue, a kind of fingerprint, a signature so small you'd never notice it, yet so distinct it can help solve a planetary mystery. That signature comes from something called isotopes. Now don't worry, this won't be a chemistry lesson in the strictest sense. We'll take it slowly, like the ripple of a tide, moving only as far as curiosity takes us. Let's begin with hydrogen. Hydrogen, as you may remember, is the simplest element in the universe. One proton, one electron, that's it. But hydrogen has a heavier sibling, an isotope, called deuterium. Deuterium is still hydrogen, but instead of just one proton, it has a neutron too. It's slightly heavier, slightly rarer, and behaves just a little differently. When hydrogen bonds with oxygen to form water, some molecules will include regular hydrogen, some will include deuterium. That ratio between the two is what scientists measure. Earth's ocean water has a known ratio. We call it the DH ratio, deuterium to hydrogen. And this is where things get interesting. When scientists began studying comets, sampling their water vapor using spacecraft, spectrometers, and telescopes, they discovered something surprising. Many comets have water with a different DH ratio than Earth's. Some comets, especially those from the Oort cloud, have much more deuterium than Earth's oceans. Others have less. A few are somewhat close, but not quite right. This discovery was like finding a puzzle piece that almost fits, but not fully. It made scientists pause. If comets were the primary source of our water, shouldn't the DH ratio match more closely? So now the mystery deepens. Comets, once thought to be the main deliverers of Earth's oceans, suddenly seem less likely. Their chemical signature doesn't line up perfectly. Their fingerprints don't match the crime scene. Of course, this doesn't mean they didn't play a role. Some water may have come from comets. Maybe certain comets have the right ratio. We just haven't found them yet. Or maybe they contributed in a small supporting way. But the evidence now points elsewhere, and scientists turn their gaze back to asteroids, specifically a kind called carbonaceous chondrites, dark, primitive meteorites that also contain water. When the water in these space rocks was analyzed, the DH ratio was much closer to that of Earth's oceans. It was a better match, a stronger clue. It suggested that perhaps it wasn't comets, but asteroids that played the larger role in hydrating the Earth. Now imagine this. You're floating above a young, chaotic planet. Earth, still forming, is spinning through a cosmic shooting gallery. Icy rocks, some large, some small, slam into its surface day after day. Each one delivers not just destruction, but droplets, minerals, chemistry, potential. Some carry water that matches Earth's signature. Some do not, but all of them add something. All of them leave a trace. The DH ratio, that quiet little number, acts like a guide. It whispers which rocks came closest to home, which ones helped turn a hot, rocky world into a blue oasis. It's a beautiful reminder that sometimes the biggest questions are answered by the tiniest details, that even when stories seem complete, there's always more to learn, a closer look, a deeper truth. So while comets may not be the sole source of our seas, they are still part of the tale. They still graced our skies. They still danced near the sun and left glowing trails of ice and dust. And perhaps even in small ways, they helped our planet become what it is. The ocean's origin, it turns out, is not a single event. It's a symphony of collisions, a conversation between heat and ice, a balance of chemistry and chance. And somewhere in that quiet balancing act, a tiny difference in weight, a single neutron, helped us tell one story from another. If there's one thing the story of water teaches us, it's that the truth is rarely simple. At first, scientists hoped for a neat answer. Maybe water came from volcanoes, or perhaps icy comets, or even ancient asteroids that struck Earth during a cosmic storm. Each theory had its time in the spotlight, like waves trying to take credit for the tide. But nature doesn't always follow a single path. The more closely researchers looked, the more they realized that Earth's water likely has more than one parent, more than one home, more than one origin story. It is not a single thread, it is a tapestry. Let's drift through that idea gently. First, from deep within Earth. Even before oceans spread across its surface, Earth held water in its rocks. Inside the mantle, beneath the crust we walk on, molecules of hydrogen and oxygen were locked in minerals. Volcanic eruptions didn't just spew lava, they breathed out steam. Over millions of years, that steam may have cooled, condensed, and fallen back as rain, drop by drop, storm by storm. This process is called outgassing, and it may have started filling the skies with clouds long before oceans ever formed. It gave Earth its first sips of moisture, its first humid breath. But that steam alone could not account for all the water we now see. The seas are vast, deeper and wider than what steam alone could fill. So scientists look to the sky. Asteroids, icy rocky travelers from the cold belt beyond Mars. Some of them, especially those dark and ancient ones, carbonaceous chondrites, carried water inside, not liquid, but locked in minerals and chemical bonds. When these asteroids struck the young Earth, they didn't just scar the surface, they delivered tiny doses of water, and over time, those tiny doses added up. The chemical signature of their water, the deuterium to hydrogen ratio, matches closely with Earth's oceans, like puzzle pieces finally clicking together. It's strong evidence that these ancient rocks helped turn Earth from fire to flow. Then there are the comets, the icy poets of the solar system, beautiful, mysterious, and made almost entirely of frozen gases. They too visited Earth in its early years, sweeping in from the outer reaches, crashing in bright explosions, and perhaps leaving behind snowflakes of their own. But as we learned, not all comet water matches Earth's. The fingerprints don't line up perfectly. Still, some comets do come close, especially those from the Kuiper Belt. Maybe not the whole answer, but maybe a small part of it. This is where science begins to shift from a single melody to a chorus. Volcanoes whispered water into the sky. Asteroids flung it down from the stars. Comets gifted it in glittering arcs. Each source added something. A few drops here, a little vapor there. Together, over millions, perhaps billions of years, they created something no one source could have built alone. Our oceans. And maybe that's the lesson here, that life's greatest gifts often come not from a single act, but from many hands, that complexity is not confusion, it's collaboration, that the water you drink, the rain you hear at night, the tears you cry, and the waves you watch crashing onto a shore are all part of a long, patient symphony between rock, fire, and ice. Some of it may come from deep inside this planet, some from ancient collisions, some from icy fragments born in the darkness between stars. It all came together somehow to make Earth not just a planet, but a world, not just warm but wet, not just habitable, but home. Even now, that combination continues. Water cycles through clouds and soil, rivers and roots. It rises in steam from hot springs, falls in snow, sits quietly in underground aquifers. It moves with us and through us. We are, after all, made mostly of water. We carry its ancient story in every cell. And as we sleep tonight, it's humbling to think none of it came from just one place. It took the universe working together. And that is beautiful. Not too hot, not too cold, just right for water to stay. Let's pause for a moment. Imagine the vastness of space stretching endlessly in all directions. Stars flicker like distant candles. planets whirl in quiet orbits, comets drift like frozen whispers, and in all that cold, dark, magnificent expanse, here we are, spinning on a little blue world. But this world, our Earth, isn't just lucky to have water, it's lucky to keep it. And you see, water is a delicate thing. It can vanish in a blink if the conditions aren't just right. Too hot, and it steams away into the sky. Too cold, and it freezes into silence. For liquid water to exist, there must be balance, a very narrow window where temperature, pressure, and distance from the sun all align in harmony. Scientists call this delicate band the Goldilocks zone, named after the old fairy tale of a little girl who searched for things that were not too much of one thing or the other, but just right. Too hot, too cold, just right. That's the magic Earth found. Let's drift slowly through what that really means. And Mercury, the planet closest to the sun, is scorched. Its days are fiery enough to melt lead. Water cannot survive there. It would boil away before a drop could settle. Then there's Venus, the second planet. It once might have had oceans, or clouds, or rivers long ago. But now it's a greenhouse world. Its thick atmosphere traps heat like a pressure cooker. Surface temperatures soar past 800 degrees Fahrenheit. If water ever existed there, it has long since vanished, lost to space or cooked into vapor forever. Then we reach Earth, third rock from the sun. Not too close, not too far. Here, the sunlight is strong enough to warm the oceans, but gentle enough to let them stay. We sit in the perfect zone where ice can melt, steam can cool, and water can remain. Water? This balance allows rivers to flow, clouds to form, rain to fall, life to flourish. But just beyond Earth lies Mars, the red planet, cold, dry, and lonely. Once it too may have danced with water. There are signs of ancient riverbeds, frozen lakes, and even polar ice caps. But today Mars is too far from the sun. Its thin atmosphere can't hold in warmth. Its water has mostly frozen or escaped into the vacuum above. And farther out still lie the gas giants Jupiter, Saturn, Uranus, Neptune. Their moons carry ice. Some even have subsurface oceans, like Europa and Enceladus. But on the surface, it's far too cold for liquid water to last. Any drop would freeze before it could ripple. So you see, Earth sits in a rare and precious space, a place where water can dance through all its forms, ice, liquid, vapor, and return again and again in an endless cycle. This positioning is not random, it's a quiet miracle of orbit and distance. But there's more. Earth's tilt helps regulate the seasons. Its atmosphere traps just enough heat. Its magnetic field shields us from solar wind that might strip water away. Every element works together. If Earth were slightly closer to the sun, oceans would boil. If it were farther, they would freeze. A shift of just a few million miles in either direction could mean a world without rivers, without clouds, without life. So when we look up at the stars and wonder if water exists elsewhere, we must remember how fragile that balance is. It's not just about having water, it's about keeping it. And Earth, our pale blue dot, does exactly that. Because it lives in the Goldilocks zone. Not too hot, not too cold, just right. Tonight, as you drift towards sleep, think about that balance. Think about the quiet miracle of sunlight landing gently on the sea, about the way water waits patiently for warmth, then flows into motion. Think about how perfectly placed our planet is, not by design perhaps, but by chance, a chance that made all the difference. And perhaps tomorrow, when you sip a glass of water or watch rain slip down a window pane, you'll remember that drop exists only because Earth found the sweet spot in space, a place where water can stay, a place we can call home, where solar wind whispers water into being. Let's take a quiet moment to imagine something nearly invisible, and not oceans, not rivers, not glaciers or clouds, but tiny floating specks of dust, so small they would vanish between your fingertips, dust that drifts between planets, through moonlight, and across the cold, dark canvas of space. Now imagine each of those specks as a miniature workshop, not made of gears and wires, but of atoms, sunlight, and time. For centuries, scientists have searched for the origins of Earth's water in massive events, volcanoes roaring, comets crashing, ancient impacts echoing through time. But now a newer theory invites us to look smaller, much smaller. To look at the dust. You see, space isn't truly empty. It's filled with particles, tiny grains of rock and metal and ice, leftovers from stars, planets, and other cosmic births. These grains are everywhere, floating between worlds, resting on asteroids, even falling to Earth in gentle streams we call cosmic dust. And riding on the winds of the sun comes hydrogen. That same hydrogen, the most basic element in the universe, flies through space in constant streams. We call it the solar wind, a breeze of charged particles blown outward from the sun's fiery surface. It rushes past planets and moons, touching everything in its path. Now, here's where something magical happens. When solar wind collides with cosmic dust, especially dust that contains minerals like silicates or oxides, something begins to stir. The hydrogen from the solar wind embeds itself into the surface of the dust grain, and if that dust already holds oxygen, a quiet reaction can take place. Hydrogen meets oxygen, and in the tiniest workshop imaginable, water is born, not in drops, not in puddles, but in single molecules, slowly forming on the surface of a speck no bigger than a grain of sand. It sounds impossible, but in the vast silence of space, even the impossible has time to happen. This process doesn't create oceans overnight. It's a slow and quiet alchemy. But over millions of years, as dust gathers, moves, and merges into rocks, asteroids, and eventually planets, these tiny amounts of water may build into something greater. Think of it like baking. Each dust grain is like a tiny flour particle. Each hydrogen ion is a drop of oil. Alone, they mean little, but together, with the right conditions and just enough heat from sunlight or cosmic energy, they transform into moisture, into something Earth could one day drink. It's an elegant theory, one that doesn't require comets or volcanic eruptions or wild impacts, just the gentle touch of sunlight, the whisper of wind from our star, and the steady patience of time. What's especially exciting is that scientists have begun to find evidence for this. Samples brought back from the moon show traces of water molecules in the upper layers of lunar dust. And remember, the moon has no atmosphere, no rain, no flowing water, but it does face the solar wind, and it does have dust. So maybe, just maybe, this quiet reaction is happening more often than we thought. Not just on Earth, not just in distant galaxies, but all around us, on asteroids, on Mars, on Mercury. Even now, this process may still be weaving water into the fabric of our solar system, one atom at a time. It's a reminder that the universe doesn't always need violence to create. Sometimes it builds with gentleness, with stillness, with dust and light. Tonight, as you settle in, think of that. Think of the sun's invisible breath streaming through space. Think of it brushing across ancient grains of cosmic sand. Think of it leaving behind hydrogen footprints on drifting stones. And somewhere far from sight, a tiny droplet begins. A molecule, a promise, a first step toward the oceans we know today. This hidden factory doesn't roar, it doesn't burn, it doesn't crash or collide. It hums, softly, like a lullaby in the dark, like the distant echo of rain that hasn't yet fallen. And when you sip water tomorrow, when you wash your face or boil tea or watch rain soak the sidewalk, you might just remember that some of those molecules were whispered into being long ago, in dust, by light, with love. Why did Earth hold on to water while others let it slip away? Before we had telescopes or satellites or rovers crawling across distant sands, we used to think Earth was the only watery world, the only one with rain, the only one with rivers, lakes, and oceans that rocked and whispered to the moon. But now we know the truth is far more mysterious. Because once upon a time, Mars had water too. Not just a little. Winding canyons, branching deltas, dry riverbeds etched into stone that is older than memory. The red planet that now looks so barren was once blue in places. It may have had clouds and puddles and maybe even shallow seas that danced beneath ancient Martian suns. And it wasn't just Mars. Venus, our sister in the sky, may also have held water long ago. Some scientists believe it even had oceans before the heat came, before everything boiled away and left behind a choking sky and burning winds. So here's the quiet question that lingers. Why did Earth keep its water when so many others let theirs go? Let's drift gently into that mystery. Water, as we've seen, is fragile. It's easy to lose. When a planet is too small, like Mars, its gravity isn't strong enough to hold on to light gases. The atmosphere slowly leaks into space, bit by bit, molecule by molecule. It's not a violent escape. It's more like a slow exhale that never ends. And when the air goes, the water follows. Exposed to sunlight, water vapor gets broken apart. Hydrogen drifts off into space, and what remains turns dry, dusty, and cold. That's one reason Mars lost its water. Another is its magnetic field, or rather the lack of one. You see, Earth has an invisible guardian, a magnetic field that surrounds us like a quiet shield. It's created by the motion of molten iron in Earth's core, spinning slowly deep beneath your feet. That magnetic field deflects the solar wind. It pushes away those streams of charged particles from the sun that can strip away an atmosphere over time. Mars lost its magnetic field early. We're not sure exactly why, but once that happened, it became vulnerable. The solar wind blew straight into its sky and began peeling it away. The planet couldn't protect its air or its oceans. Venus had a different problem. It's about the same size as Earth, but it's far too hot, close to the sun, wrapped in thick clouds of carbon dioxide. Venus became a runaway oven. Any water that once existed boiled into vapor, and then, under the glare of sunlight, broke apart into gases that escaped into the void. So Venus may have started wet, but it couldn't stay that way. Earth, on the other hand, had just the right conditions. Large enough to hold on to an atmosphere. Not too hot, not too cold. Protected by a magnetic field that still spins today. Our air stayed, and so did the moisture. It rained, it pooled, it carved valleys and filled seas. It soaked into soil and surged up through springs, and it stayed. Sometimes we call this the Goldilocks principle. Earth isn't the biggest planet. It isn't the closest to the sun. It doesn't have the thickest atmosphere or the fastest spin, but everything was just right. Just right for oceans to survive. Just right for clouds to drift and return. Just right for life. Tonight, think about that. Think about how easily we could have been Mars. Dry, frozen, waiting in silence. Or Venus, drenched in heat, a sky too thick to breathe. But instead, you live on a planet where rain still falls, where rivers still run, where lakes shimmer under moonlight and oceans speak in waves. All because a few things held together. Because gravity hugged the air close. Because a magnetic field spun strong and silent. Because the sun warmed us gently, but not too much. Earth kept its water, and that water kept Earth alive. So as you close your eyes tonight, listen to the sounds around you. Maybe there's the hush of wind, maybe the drip of a faucet, maybe a memory of rain outside your window. It's easy to forget how rare that is. But how precious. How lucky. And maybe, just maybe, that's why we feel so calm near water. Why a bath, a beach, or a soft rain can make us feel safe. Because deep down, our bodies remember. They remember that this planet didn't let go. The invisible force that helped water stay. If you could peel back the layers of our world, like opening a quiet book page by page, you'd find something surprising at its center. Not silence, not stillness, but movement, slow, molten motion, a liquid core of metal, mostly iron and nickel, swirling deep beneath your feet, churning, spinning, breathing heat. This restless heart does something wonderful. It generates a shield, not one you can see or touch, but a magnetic field that surrounds our entire planet, stretching far beyond the clouds, reaching into the silent dark between Earth and space. Like an invisible cocoon, it wraps us in protection. We call it the magnetosphere, and it may be one of the main reasons we're still here. You see, the sun is not just warm and bright, it's powerful. Its surface constantly crackles with energy. It sends out streams of charged particles, tiny bullets of light and heat, called solar wind. This wind races through the solar system. It's fast, fierce, and when it reaches a planet without protection, it can do real harm. It strips away the atmosphere. It tears at the sky. It peels molecules apart, one by one, like time undoing a painting. That's what happened to Mars. Without a magnetic field, it was left exposed. Its air grew thin. Hope you enjoy squatting covered covdwerkta. Its water escaped, and its blue moments faded into red. But Earth was different. Because of that swirling metal center, our magnetosphere rose like a quiet guardian. When solar wind hits it, the magnetic field doesn't just absorb the blast. It bends, it curves, it redirects the storm around us, sending those particles into harmless spirals, away from the places we live, breathe, and dream. It's like standing behind a glass wall during a downpour. You can see the rain, you can feel the pressure, but you stay dry, protected. That's what the magnetosphere did for Earth, especially in its youth. Billions of years ago, when our planet was still young and fiery, the sun was even more aggressive than it is today. Its winds blew stronger, its flares were louder, and yet somehow our thin, fragile atmosphere held on. Not all of it, of course. Some gas escaped, some particles fled into space, but not enough to erase the sky, not enough to lose the water. The magnetosphere stood firm, and because of that, clouds could form, rain could fall, rivers could run, oceans could deepen, Erin Kovtaire, but the sea, and where heen orks buddy of touched arty, avtyrik, but the sea to nowhere duzzled. Hope you understood mir arty tolping, the Tesselter censureds arty told, that was the beast wrought in seed, be question for, and life, one day, could begin. It's humbling, isn't it? That something so invisible could matter so much. We rarely think about Earth's magnetic field. It doesn't make noise, it doesn't flash or sparkle. You can't see it swirl around your hands, but it's always there, shielding you from a storm you didn't even know existed. Sometimes you can glimpse it, not with your eyes open wide in daylight, but with your head tilted toward a cold, clear night in places like Iceland, Canada, or the far south of New Zealand. There, when the solar wind presses too hard, it pushes some particles down through the magnetic field, and when they touch the upper atmosphere, they dance. We call that the aurora, northern lights, southern lights, ripples of green and pink and violet swirling like dreams against the stars. It's the magnetosphere glowing softly, showing us it's still watching. So the next time you stand beneath a sky full of color, remember it's not just a beautiful light show, it's the fingerprint of a protector, a sign that Earth, even in its silence, is fierce in defense. Without it, our atmosphere might have thinned, our seas might have vanished. And this calm moment, this sleepy story, might never have happened at all. Tonight, as you close your eyes, imagine that shield still spinning below you. Feel the comfort of it. Not loud, not sharp, just steady, strong, like a heartbeat inside the planet itself. Whispering always, I've got you. I'm holding on, how Earth's silent companion shaped our watery world. If you look up on a clear night, you might see it glowing softly above you. Not flashy, not fiery, just quiet, constant, familiar, and the moon. It has watched over our world for billions of years, a pale witness to everything that ever happened here. But it's not just a pretty face hanging in the sky. The moon has been helping us all along. Not loudly, not obviously, but in quiet, gentle ways that shaped the course of life itself. You see, the Earth is not perfectly steady. It spins on a tilt. That tilt about 23.5 degrees is the reason we have seasons: spring and summer, fall and winter, warm rains, snowy mornings, changing skies. But left on its own, Earth's tilt would wobble. Over time, the planet would lean too far, then not far enough, like a spinning top that slowly loses balance. That might sound small, but it would be a disaster. Without steady seasons, the climate would swing wildly. Glaciers might form in places meant to be warm, rainforests might dry out, ocean currents could stall, the rhythm of life would break. But the moon is there, like a hand gently steadying the top. Its gravity tugs on Earth, not enough to stop the spin, just enough to smooth the motion. This quiet pull keeps our tilt stable, not locked, not frozen, but steady enough for balance, for rhythm, for life. And that's not all. The moon also gives us tides. When it pulls on Earth, it pulls harder on the oceans. That stretch of water chasing the moon's gravity creates a tide. The water rises, then falls, every day, twice a day. This movement stirs the seas. It mixes warm and cold. It shapes coastlines. It carves estuaries. Long ago, in the very beginning, tides might have done something even more important. They may have stirred the chemical soup of early Earth, mixed it, spread it, and helped tiny molecules find each other in the tide pools, maybe even helped spark life. And over time, those tides kept shaping the planet. They guided the rhythm of animals and plants. The moon's gentle beat echoed in the bodies of crabs, birds, and even us. Even now, some people say they sleep differently during a full moon. Maybe it's just myth, or maybe it's the quiet echo of an ancient rhythm we've forgotten we follow. But beyond the tides and the tilt, there's something else the moon may have done. It may have helped Earth keep its water. You see, without that stabilizing pull, Earth might have spun out of control. The tilt might have changed so much that ice melted too quickly or froze too fast. Oceans could have turned to steam or been locked in glaciers forever. But with the moon's help, Earth stayed balanced. And you just tilted enough for weather to change, but not so wild that it destroyed the water cycle. Rain could fall, snow could melt, rivers could flow to the sea and come back again as clouds. A perfect loop. But all because of a moon that doesn't speak, doesn't shine its own light, doesn't make a sound. It just helps, and it didn't always exist. The moon was born from violence. Long ago, a planet the size of Mars slammed into Earth. The impact sent rock and dust flying into space. That debris circled the planet, clumped together, and became the moon. From chaos came calm. From fire came balance. Tonight, when you glance up at the night sky, know this: that calm, glowing shape didn't just light the path for travelers. It didn't just inspire poets and lullabies. It helped create the conditions that made life here possible. It steadied our seasons. It stirred our seas. And it may have helped Earth stay wet, blue, and beautiful. Not by force, not by command, but through presence, through patience, through quiet pull. So as you lie there, soft in bed, listening to the hush of night, remember the moon is out there too, floating, watching, helping, just as it always has. They hold heat, nutrients, and life. Earth's oceans shaped climate and carved land. When we think of the ocean, we often imagine the surface first. First, gentle waves, shimmering blues, the soft hush of water meeting shore. But the ocean is not just a big bowl of water. It is far more than that. It is deep, alive, and powerful. And the more we look beneath its surface, the more we begin to understand just how much it shapes our world. Let's drift there now. Beneath the waves lies a place that is both ancient and always changing, a place that doesn't just hold water, but stores the memory of Earth's past and the energy of its future. First, let's talk about heat. The ocean is Earth's great thermal blanket. Sunlight warms its surface by day. At night, that warmth doesn't vanish. It lingers. The ocean absorbs and holds the heat. Slowly, deeply, silently, deeply, silently. In fact, the ocean has absorbed more than 90% of the excess heat trapped by our changing atmosphere. That warmth sinks down, layer by layer, carried by currents that stretch across the globe. Without the ocean's ability to store heat, our planet's climate would swing wildly. Days would burn, nights would freeze, storms would rage far worse than they do now. Instead, the ocean smooths those extremes. It breathes warmth into the air in winter and coolness in the summer. It guides winds, shapes rainfall, and keeps tropical storms alive, or sometimes keeps them from forming at all. All this without a sound. We'll uncover, but the ocean doesn't just hold heat, it carries nutrients. Think of every leaf that falls, every mountain that crumbles into sand, every river that empties into the sea. All of it brings minerals, iron, phosphorus, nitrogen into the water. Tiny pieces of land dissolve into the vast blue, carried by waves and pulled into deep currents. These nutrients feed the smallest of life forms, microscopic phytoplankton. They are invisible to the eye, but they are the beating heart of the ocean's food web. Floating near the surface, they turn sunlight and carbon into energy. They breathe out oxygen. In fact, they create more than half the oxygen we breathe. From these tiny beings, life ripples upward into fish, whales, seabirds, and eventually into us. Every breath we take is touched by the ocean. Every bite of seafood, every drop of rain, every breeze off the shore. But the ocean also shapes the very land we live on. Over eons, the steady pulse of waves has carved cliffs, hollowed caves, smoothed stones. Tides have filled estuaries and emptied salt flats. Storm surges have rearranged coastlines, and every time glaciers melted or reformed, the ocean's edge moved, sometimes forward, sometimes back. Over time, it traced the outlines of continents, and under the surface, the ocean has ridges taller than mountains, trenches deeper than Everest is high. Earthquakes ripple through its floor, volcanoes erupt in the dark, and life, strange and glowing, clings to vents where fire meets water. It is a world unto itself, and yet it speaks to everything else, and the ocean and the sky are in constant conversation, through evaporation, through wind, through storms that rise in the tropics and travel for days, fueled by the warmth of sea below. And even the moon, quiet and far, still pulls at the tides, reminding us that the ocean is never still. It breathes, it shifts, it listens, and through it all, it remembers. Because locked within the ocean's depths are secrets of the past, trapped gases, buried fossils, ancient salt. If we read it carefully, the ocean can tell us what Earth was like millions of years ago, and maybe what it might become. So tonight, as you close your eyes, think of the ocean not as a single thing, but as a story in motion. A story of heat, of life, of memory. A story that touches every part of this planet, even the part you're lying on right now. From the warmth in the air to the rhythm in your breath, the ocean is there. Not just water, but energy, balance. Pud o ostein stad, pud one turdius herd, tainer a lair, pud wale don, or tanale first moldal lauk, utan, breathes with pudal to father's other glurgy thing, and life itself. And water isn't just a solvent, it enabled the first molecules of life to meet, react, and evolve. Somewhere long ago, in a shallow pool or deep ocean trench, something amazing happened. Not something loud, not something we'd recognize as alive, but something important. Two molecules met, then another, and another. And with each meeting, each gentle bump in the watery dark, something new began to stir. This is the quiet beginning of life, and water was there for all of it. Let's float there now. In its simplest form, water is just H2O, 2 hydrogen atoms, 1 oxygen. It seems almost too ordinary to be magical. But water is special, very special. Unlike most liquids, water has a strange shape. It's bent like a tiny V, and this shape gives it an incredible ability. It can stick to things, it clings, it connects, it surrounds. That's what makes water the perfect medium for chemistry. You see, when molecules are floating in water, they're not stuck in one place. They move, they spin, they bump into each other, they stretch and break and reform. And when those molecules are just right, those bumps can become reactions. In the early Earth, the oceans were filled with molecules: carbon, nitrogen, hydrogen, sulfur, phosphorus. And in water, these elements had a chance to dance. Over time, simple molecules formed more complex ones: amino acids, fatty acids, sugars, the building blocks of proteins, membranes, and eventually life. But it didn't happen all at once. The life didn't arrive with a flash. It arrived slowly, quietly, like a tide creeping in. And the water was more than just a background. It helped choose what could survive. Only certain molecules can work in water. Only certain shapes, certain bonds. So the very first chemistry of life was shaped by the nature of water itself: its temperature, its pH, its salt, its ability to hold heat and dissolve solids, its motion and depth and clarity. All of these things decided which molecules could thrive and which would fall apart. Water created a stage where the drama of life could unfold. Let's imagine a tiny bubble floating near a warm vent on the ocean floor. Inside, a few lucky molecules find each other. They form a membrane, a shell, something that holds together. Inside this bubble, more reactions occur. Energy is trapped. New chemicals are made. Information starts to be copied. Not perfectly, but often enough to matter. And now we have something new. We'll uncover to the parlor the carried bull, and when Havamol Hingdhal and here showcast. Not quite alive, but not quite lifeless either. It can grow, it can divide, it can change, and most importantly, it can evolve. Over time, these little chemical systems become more stable, more efficient, more complex. They find ways to make energy, to store it, to protect themselves. And eventually they begin to pass down patterns, tiny molecular instructions that say, do this again. This is the beginning of life as we know it. And water made it all possible. Without water, molecules wouldn't move. They wouldn't collide. They wouldn't react. Without water, there is no chemistry. Without chemistry, no biology. Water is the great connector. Even today, every living cell on Earth is filled with water. It surrounds DNA, cushions proteins, delivers nutrients, removes waste. It carries signals, transports heat, and provides structure. Every heartbeat, every breath, every thought, all of it happens in water. And if we look outward, to the moons of Jupiter or the ice of Mars, we still look for water first. Because where there's water, there might be life. So tonight, as you settle into sleep, imagine that moment long ago. A warm puddle beneath a volcanic sky. Tiny molecules drifting, meeting, bonding, becoming something new. Ura. And know that in every cell of your body, that ancient chemistry continues quietly, faithfully, drop by drop. At the bottom of the ocean, mineral-rich vents may have been the first cradle of life. Let's journey downward now. Now, past the waves and sunlit ripples, deeper than the diving whales, beyond where light can follow, all the way down to the seafloor. Here, in the darkest depths of the ocean, the world feels still. But it is not. Bu hides you a debt their hand. Beneath the silence, Earth is breathing. At the edges of tectonic plates, cracks split open the ocean floor, and from these cracks, something ancient rises. Hope you warmth, not the warmth of sunlight, but the warmth of Earth's core. Hot, mineral-rich water shoots up from beneath the crust in tall, billowing plumes. And these are hydrothermal vents. To the eye, they look like underwater chimneys, spires of black or white smoke rising into the sea. But the smoke is not smoke at all. It's water, superheated by the rock below, loaded with dissolved minerals and gases. And here, in this shadowy world, something incredible may have happened. Life? You see, unlike the surface world, this place does not need the sun. It has its own energy, its own chemistry, its own story. Around these vents, the water is rich with hydrogen, methane, and sulfur. Minerals ooze from the rocks and settle into structures, walls, chambers, tiny pores. And inside those pores, warm water flows in and out like a breath. Now imagine this. Air. Tiny molecules drift in. They bump, they mix, they react. Just like we spoke of before, only now, the environment helps guide them. These mineral pockets act like natural laboratories, concentrating ingredients, providing heat, and shielding them from the cold. Scientists believe these vents might have offered the perfect conditions for life to begin. They are warm, wet, and chemically rich. They provide energy from the earth itself, and they create boundaries, little spaces where early chemistry could become something more. And for Mendigwag, Luvkaldip, Parting, it's in these spaces, perhaps, that simple molecules became complex, where amino acids linked into proteins, where bubbles formed, holding their reactions inside, and where, drop by drop, life took its first steps. Even today, hydrothermal vents are home to strange and beautiful creatures. Giant tube worms with no mouths, clams without eyes, microbes that eat chemicals instead of sunlight. These living fossils remind us life does not need light. It needs chemistry. It needs shelter. It needs water. The hydrothermal vent theory is just one idea. There are others: warm little ponds, ice-covered lakes, comet-borne seeds. But there is something quietly powerful about this deep-sea origin. Something ancient, something hidden, a beginning that didn't rise with the dawn, but bloomed in the dark. And maybe, just maybe, it still does. Because when we look at icy moons like Europa or Enceladus, we find signs of oceans beneath their frozen crusts. We wonder, do they have vents too? Could life be simmering, silently, beneath alien seas? It's a beautiful thought, that across the cosmos, wherever water meets warmth and rock, the recipe for life might stir. And it all may have started right here, in the deep, in the quiet, in the slow breath of the ocean's floor. So as you rest tonight, picture that distant world beneath the waves. Not cold, not lifeless, but full of mystery. A place where life was not sparked in fire or light, but in warmth, in minerals, in silence. A place where the ocean met the earth and something new was born. Sleep gently, dream of ocean floors and ancient breaths. And remember, part of you still carries that beginning. That same water, that same wonder, the quiet heartbeat of the very first life. Every living thing depends on water. It's the stage where biology performs. If you take a deep breath right now and place your hand gently over your heart, you'll feel it. Can you feel it? Viewer time air. Now we're the frioors in farventus wolp. We'll feel a bulb labber van eve. De huurv openten sate. Of adzation and specially pasquamen, be reorienting sempielde, huard soldiers with a teeve. That soft, steady rhythm beneath your ribs, a quiet reminder that you are alive. But what you won't see, and what's easy to forget, is that this life pulsing through you is mostly made of water. More than half of your body, more than half of mine, is liquid, not just flowing in veins, but living in cells, nestled between atoms, cradling your very chemistry. Inside every cell, there is water, tiny, invisible pools where the magic of life unfolds. Without it, biology would fall silent. Because water is not just something we drink, it's the stage, the medium, the silent partner in every performance. Imagine a single cell, too small to see, a droplet, sealed in a bubble of membrane. It floats in a larger sea, but within it, a smaller sea swirls. And in that miniature ocean, incredible things are happening. Proteins fold and twist. DNA coils and unwinds like an ancient scroll. Messages travel. Energy flows. Life begins. But all of it requires water. It cushions. It transports. It dissolves. Water breaks things apart and helps them come back together again. It keeps molecules moving, keeps reactions swift but soft, like dancers gliding across a gentle floor. Think of it like this. Without water, a cell would be like a concert hall with no air, no echo, no movement, no life. Because even the simplest life needs a place to unfold, and that place is water. It is where chemistry breathes, where enzymes dance, where signals are whispered across membranes, where energy is passed from molecule to molecule like a glowing torch. And this isn't just true for humans, it's true for ferns and jellyfish, and for mushrooms and elephants, and well, for algae floating in distant ponds, and for ancient microbes tucked inside ocean rocks. From the moment life first appeared, water has been the quiet companion, the silent environment that allowed it all to happen. Scientists sometimes call it the universal solvent, but really, it's the universal stage, the setting for every act in the grand play of life. And it doesn't just sit still, it moves, it carries signals, it powers pumps and presses, it shapes the inside of a cell the way gravity shapes the curve of a planet. Water helps cells divide, it helps membranes bend, it helps waste exit and nutrients arrive. Every heartbeat, every breath, every moment you've ever had was made possible by water in your cells. Even thoughts, those invisible sparks dancing through your brain, depend on it. In your native pen, neurons fire with the help of ions, and those ions float, of course, in water. So in a way, your very ability to wonder where water came from depends on the water inside you. It's a beautiful loop. Water created the conditions for life. Life built structures to carry water. And now, here we are, carrying the same molecules that once drifted through deep space, the same drops that may have steamed from ancient vents, the the same mist that fell from the first clouds. Inside every one of your cells, there's a story billions of years in the making. A whisper from the stars, a memory of comets, a quiet ripple from the first oceans. And it all happens in water. So as you relax now and let your breath slow, remember this: you are not just surrounded by water, you are made of it. Each cell a tiny sea, each heartbeat a tide. And just like the oceans, you carry life forward, quietly, beautifully, in waves too small to see. Water isn't rare. It's been found in interstellar clouds, on moons like Europa, and on distant exoplanets. When we think of water, we often think of home, a river winding through a forest, waves lapping at a beach, and rain tapping gently on a roof as we fall asleep. Water feels like something Earth gave us, like a secret the universe shared with only us. But the more we look out into the cosmos, the more we realize something extraordinary. Water is not Earth's secret, it is the universe's signature. We'll uncover for Bring and Profustul Septgur, Corp, Put out there, across the vast black canvas of space. Water is everywhere. Not always in oceans, not always flowing, but it is present in whispers and fragments, in steam and ice, written into the fabric of the stars. Let's begin far away, beyond our solar system, beyond even our nearest stars, in the cold, dark clouds between galaxies, what scientists call interstellar space. There, hidden in those thick, dusty clouds, lie icy grains laced with molecules of water, floating quietly for millions of years, waiting. We've pointed our instruments at these ancient clouds and found the unmistakable signature of water, not in drops, but in vapor, in mist, in chemistry that echoes what we see here on Earth. Water was not born here. It was traveling the stars long before Earth even existed. And then there are the planets, the ones that orbit far-off stars. We call them exoplanets, worlds beyond our solar system, too distant to touch, but close enough to study. Some of these planets we've discovered have thick, steamy atmospheres, and inside those hazy layers, we've detected water vapor. We can't yet see their oceans if they have any, but the signs are promising. Hints that water may flow there too, that rain may fall, that alien clouds may drift across alien skies. Closer to home, the story continues. Our solar system, as quiet as it may seem from Earth, is teeming with places that hold water, and water on Mars. Ancient riverbeds snake across the surface. Frozen ice hides beneath the soil, and at the poles, caps of ice wait through long Martian winters. Farther out, Jupiter's moon Europa wears a cracked shell of ice. Beneath it, scientists believe there may be a global ocean, vast, deep, and warmed from below by the moon's restless core. Saturn's tiny moon Enceladus surprises us even more. It sprays water out into space. Little geysers burst from its surface, like whispers from a hidden sea below. Even in the darkest, coldest corners of our solar system, water endures. Some comets spend their lives frozen and asleep, but when they drift near the sun, they wake, and tails of vapor stretch behind them, as if remembering the oceans they once might have helped create. What all this tells us is simple and stunning. Bekoningsbrigioen. You've after or vesterupt Bekoningsbregst for breg. You've had I don't bat aftero, and te no, and because prefer to said, prefer to sake of past and vreeds weak cur. Water is not rare. It is not precious because it is scarce, and it is precious because it connects, because it is familiar, across time, across light years, babekatsix babekal. The same kind of molecule that falls from your faucet and into diet peppers can be found circling distant stars. The steam rising from your tea has ancient cousins in nebula. This means that wherever we find water, we might also find the possibility of life. Because if Earth taught us anything, it is that where water lingers, life can begin. So when you look up at the stars and wonder what might be out there, you can take comfort in this. Water has already been there. It has traveled far beyond your dreams. It has crossed the coldest spaces. It has kissed moons and hidden in shadows. It has waited on the edges of suns, and somewhere light years away, well, there might be another planet, another child of the stars, where water runs when people self for water one kong water, and maybe, just maybe, someone is watching it fall from the sky, fall and wondering, just like you, if water is common, maybe life is too. Earth is a clue, not an exception. Somewhere out there, beyond the pull of our sun, a small planet might be watching its first raindrop fall. It might not look like Earth. Its oceans might glow under a dim red star. Its mountains might rise from crystal, not stone. Its sky might shimmer in colors we cannot name. But if there is water, there is a chance. And here on Earth, life and water have always danced together. We have never known one without the other. From the very first cells in the ancient sea, to the forests, the deserts, the cities we live in today, life has always bloomed wherever water stayed. So when we look beyond our own world, when we search for something or someone, we do not start by asking, where is the life? We start by asking, where is the water? And it turns out, water is not shy. It is not rare or hiding. It is everywhere. It steams through gas giants, if night slumbers beneath ice moons, beneath ice moons, beneath ice moons, and dances in the dusty light of distant stars. That alone is stunning. But what it might mean is even more beautiful. Because if water is this common, then maybe life is not some strange accident. Maybe life is what happens when water is given time, warmth, and a place to settle in. Think of it like a recipe. You need ingredients, and you need the right conditions, and you need time, billions of years, sometimes, for things to come together in just the right way. And Earth, it seems, is proof that this recipe can work. Not just once, but maybe over and over again. Maybe on planets circling small, quiet stars. Maybe beneath the frozen crust of Europa. Maybe in clouds high above a gas giant. Maybe somewhere we cannot even imagine yet. It is a gentle, hopeful thought that we might not be alone, not because of some science fiction miracle, but because of something simple, something clear, and something wet, something we hold in the palms of our hands every day. Water. Of course, we have no proof yet. We have not found aliens. We have not heard any voices in the dark, but we are learning to listen better. And what Earth teaches us in what Earth teaches us is that life can be small, it can be quiet. It can begin in a vent at the bottom of the sea, or drift for years through the clouds, unseen. Life does not always arrive with fanfare. Sometimes it just begins. And if it began here, then perhaps it has begun elsewhere too. Perhaps it is waiting, growing, or maybe just dreaming in the shadows, just as we are dreaming now. So when you look up at the stars tonight, remember, they are not empty. They are not silent. Sukkent wel hekli feed with of man ov, and Dr. Spukigring, the wills into docs alturi double wedges herosing woodstys. They are filled with stories waiting to be told, and many of those stories may begin with water. They not because Earth is rare, but because it might be one of many, a single drop in a vast cosmic sea, where life is not a miracle and wanting water welve betteres, but a rhythm that plays wherever water flows, where warmth holds steady, and time is allowed to work its quiet magic. Earth then is not the exception, it is the clue, the shimmering hint that the universe is not just vast, but full of potential. And so, wherever you are, whatever time it is, close your eyes for a moment and imagine somewhere, light years away, another mind just like yours, looking at its sky, pure so cover spake so fairy, could asking the same gentle question, are we alone? And maybe, just maybe, the answer is floating in a raindrop, on a leaf, not in a ripple across an alien sea, waiting, pianikumstiafanel, pievent the hauser trait, moving time from the comforting, as water often does, for someone to notice, and even compeak storing, and a locked that became porty or touch eye for Jethramin, and a vershaga that act human affecting. A single molecule of water, simple, bent, electric, holds extraordinary power. Somewhere in the quiet space between thoughts, you might picture a raindrop. It seems small, soft, simple. It clings to your window. It kisses your skin. It ripples across puddles and runs down your fingertips. But tucked inside that single drop, there is a secret so elegant. It built oceans, carved valleys, sculpted mountains. It nourished life, powered storms, cooled planets, and shaped history, all from a tiny bent shape. You see, a water molecule is made of just 3 atoms, 2 hydrogen, 1 oxygen. That's it. But they don't arrange themselves in a straight line. No, they settle into a gentle V shape, like a pair of open arms or a bird's wings mid-glide. This bend is everything. It gives water its stickiness, its flow, its ability to dissolve, to climb, to freeze, to float. It turns water into more than just a liquid. It turns it into a storyteller. Because of this bend, water clings to itself, a force called cohesion, and it also reaches outward, clinging to things like glass, soil, leaves, even your skin. That's adhesion. It's why raindrops beat up, why dew clings to grass, why tears hold shape before they fall. Inside that simple angle, water creates tension, and besim thirdamun, and water tavet pest a word, and water de def so. Not the kind that causes worry, but the kind that lets insects walk across ponds, with a, and trees pull water upward without a single pump. It is nature's quiet engineering, but it doesn't stop there. That bent shape gives water a tiny electric imbalance. One side is a little more positive, the other a little more negative. It's like a tiny magnet, pulling and dancing with the molecules around it. And because of this, water can do something no other liquid quite can. It dissolves things, and when salt, sugar, minerals, gases, water wraps around them, carries them, transforms them. It's the reason oceans are salty, the reason blood carries oxygen, the reason life began in watery soup. So this tiny bent shape, this drop, becomes a cradle, a bridge, a mirror. It reflects the world and reshapes it. Even ice, so simple, so cold, even is made magical by this angle. Most things shrink when they freeze, but water expands. It floats. This is no small trick. It means lakes freeze from the top down, keeping the life below safe and warm. It means glaciers float, icebergs drift, the planet breathes. Without this strange quirk of shape, your entire ecosystems might not exist. Neither would we, and in its liquid state, Fershine teeth, water glides. It carves. It moves with both softness and strength. A stream can wear down stone, and Ebriel spequatched fell sefteri and pubilganivigers. A river can shape a continent. A single droplet can crack concrete. If given time and patience, water is soft, but it never gives up. Now, take a moment to imagine a single molecule. Those three atoms will quietly holding hands in space. One oxygen in one, two hydrogen, and an angle that changed everything. Imagine billions of these molecules, drifting, joining, swirling together, falling as snow, crashing as waves, as floating as clouds, and resting in the glass beside your bed. This shape, the V, the bend, the bond, is not random. It is nature's poetry. Simple, silent, profound, and somehow, without ever meaning to, it taught life how to dance. So next time you touch water, whether you're washing your hands or watching rain trail down your window, pause, whisper a thank you to the shape of a drop, to the tiny asymmetry that made rivers flow and cells breathe, flowers bloom, and hearts beat. It is easy to forget, but every splash, every sip, every tide and tear begins with one quiet angle, and will how Pikebergs dele Beatrins u sigur prate. Hardumlik ulf efter munkanartechek for proceduri. Wild Tursen Kegwill, Berglid Kol from D, Berglid became a turnstray bigus the pod. And remember private wards afterwards the yet. Food well passel bigs estin from D by tick. For profsol pebbles, for schelzold breaks, bakes blade dads. From D win cried werf a cell palv, how we shram plasel pals one. From D buwin, from D bor anning and I the rew. From get breaks, 14 for bigas, and where few fewer peat in the balp or word fevel. For dubso parrots to maith. And where an hearing tory, puri durents of grilled, from D plate, from D fewer few fee, one thake, from tuer few outwards, from D pure few fee vigneer, from D plaque pigs, from tuer few fee vigneer, from D folded in the dark. From supernovas to volcanoes, comets to clouds, each drop has seen billions of years. Take a moment. Look at the glass beside your bed, or imagine a droplet resting on a leaf. Clear, silent, still. But inside that single drop is a story. A story older than you, older than me, older than me, older than mountains, trees, and even the earth itself. Because water remembers. And every molecule of water on this planet, every splash in your bathtub, every wave in the ocean, every snowflake, steam puff, or rain cloud has been on a journey, a long, long journey, spanning space, stars, eruptions, and time itself. Let's go back, way back, before there were oceans, and before the earth had air, before the sun even existed. There, in the cold dark of space, clouds of hydrogen floated like whispers. They drifted, they gathered, and in the hearts of newborn stars, fusion began. Oxygen was born. These stars burned bright, and then they exploded, and bathed Brixity Octolida Krupp, and Werk, Poikwave, just a famines proof the Pickbrun's plape, and what mimed of the Prekwarov blade, and meth just a fam, supernovas, cosmic fireworks that shattered everything, spreading new elements across the galaxy. And among these scattered ashes, in the drifting debris of broken stars, tiny grains of dust formed. Dust that carried hydrogen. The dust that clung to oxygen. And somewhere, somehow, water began. Ice microscopic, delicate, ancient formed on these dust grains. And these tiny frozen beginnings traveled. Some were swept into comets, icy wanderers roaming the edges of young solar systems. Others were drawn into asteroids, pure, rocky time capsules that would one day crash onto forming worlds. One of those worlds was Earth, a newborn planet, blazing and molten. But still, water came. It came with the crashing of meteorites, and with the icy screams of comets, with the breath of volcanoes rising from the deep. Water settled into every crack, every hollow, every dark place where it could hide. And it waited, and it waited, and it cooled, it steamed, it rained, it boiled. Over millions of years, it gathered into oceans. And there, in the salty blue, it witnessed something new. Life, the first cells, the first stirrings of biology. Water cradled those moments, watching, holding, nourishing. It flowed through single-celled creatures. It watched the rise of fish, the crawling of amphibians, the first fluttering of wings. It fell as rain on giant ferns. It thundered in ancient storms while dinosaurs roamed. It froze inside glaciers taller than skyscrapers. It steamed in volcanic vents beneath shifting continents. And it kept moving, always moving. It evaporated, condensed, rained again. It trickled through the roots of trees, and it was sipped by mammoths and woven into the wool of early creatures. It flowed in the veins of our ancestors. Every time you touch water, you're touching history. That drop on your palm may once have circled the moon as vapor. It may have been inside the belly of a whale. It may have quenched the thirst of a saber-toothed cat, or sparkled on Cleopatra's fountain. It may have boiled in a Roman bath, been crushed in the depths of the Mariana Trench, or danced in the mist of Niagara Falls. Water cycles, but it doesn't disappear. It moves, transforms, listens quietly, and it remembers. It remembers heat, live on their ingenerate. It remembers impact, and it remembers freezing stillness and chaotic floods. And tonight, as you rest your head, There is water within you too, in your cells, in your breath, in your tears. You are part of its memory now. Now, part of its story. Every heartbeat sends that ancient liquid rippling through you, a rhythm passed down from comets, from stars, caught in clouds of dust that came before planets were born. So next time you sip from a cup or watch rain trace the window pane, pause. You are holding time, billions of years, and even the fathers of medieval enteried in Filni odd-pairing home, and came and all for and duriabs of nightmaring, or torb ain, gespali they eat. Billions of memories, all contained in a clear, quiet drop. Water doesn't speak, but it never forgets. And from the tears in our eyes to the waves in the sea, water moves through all of us. Take a slow breath, in and out. Feel that rhythm, that gentle tide rising and falling in your chest. That's water, and not just in the air you're breathing. It's inside you, flowing through every cell. You are water just as much as the ocean is. We often forget that, the isbit, that nam, pake, but you are in many ways a walking sea. Your blood is mostly water, your brain too. Even your bones, yes, even the hardest parts of you carry water inside them. From the top of your head to the tips of your fingers, water is everywhere. It helps you think, feel, heal, and grow. It carries oxygen to your lungs, nutrients to your tissues, and memories across your mind. You are not just touched by water, you are shaped by it. Think about your first moment on this planet, before your eyes opened, before your lungs filled with air. You floated, not warm, weightless, suspended in your mother's womb, surrounded by amniotic fluid, a private ocean. Your first home was water, love, and when you came into the world, your first breath was followed by your first tear. Tiny, salty, and ancient, a signal to the world that you had arrived. Tears are made of water too. They carry emotion, joy, sorrow, relief, laughter. They all find their way out as droplets. Isn't that something? That even our feelings find expression through water? And when you sweat on a hot day, when your skin glistens after a run or a dance, when your hands feel damp with nervousness or excitement, that's water too. Always there, always moving. You don't have to look far to find it. Hold your hand over your heart. The beat you feel? Water is moving with every pulse. And when you speak, be bereft. Your voice rides on moisture. When you breathe out into the cold and see your breath hang in the air, that's water too. Even your thoughts depend on it. And your neurons, your chemistry, your moods, they all need water to work. But it's not just inside of us. We are constantly exchanging water with the world. You drink it from rivers, lakes, and rain. You release it when you sigh, when you cry, when you exhale into the sky. Your body doesn't just contain water, it shares it, it borrows it, and one day it will return it. So when you feel tired or overwhelmed or disconnected, remember this. You are part of the water cycle, and the same drops that once flowed through glaciers and geysers, through whales and wolves, through kings and poets, are now inside of you. And when you sleep tonight, water will still be at work, and healing, repairing, flowing. Every breath you take is part of a larger rhythm, an ancient pulse echoed in tides and rainfall. in rivers and hearts, and in lullabies and thunderstorms. Even your dreams may float upon it. So drink slowly, breathe softly, let your body remember what it already knows. You are not separate from the earth. You are not separate from the oceans. You are not even separate from the stars that gave birth to water in the first place. You are water. You are memory. You are part of the story. And tonight, as you drift off, let yourself feel that truth. Let it cradle you like waves on a shore. Tomorrow, you'll rise again, refreshed, refilled, ready to flow forward just as water always does. But for now, be still. Let go and let the water inside you rest. Good night, gentle traveler, and sweet dreams. Your first home was water, and when you came into the world, your first breath was followed by your first tear, tiny, salty, and ancient, a signal to the world that you had arrived. Tears are made of water, too. They carry emotion and joy, sorrow, relief, laughter. They all find their way out as droplets. Isn't that something? That even our feelings find expression through water? And when you sweat on a hot day, when your skin glistens after a run or a dance, when your hands feel damp with nervousness or excitement, that's water too. Always there, always moving. You don't have to look far to find it. Hold your hand over your heart. The beat you feel? Water is moving with every pulse. And when you speak, your voice rides on moisture. When you breathe out into the cold and see your breath hang in the air, that's water too. Even your thoughts depend on it. Your neurons, your chemistry, your moods, they all need water to work. But it's not just inside of us. We are constantly exchanging water with the world. You drink it from rivers, lakes, and rain. You release it when you sigh, when you cry, when you exhale into the sky. Your body doesn't just contain water. It shares it. It borrows it. And one day, it will return it. So when you feel tired or overwhelmed or disconnected, they wait. Remember this. You are part of the water cycle. The same drops that once flowed through glaciers and geysers, through whales and wolves, through kings and poets, are now inside of you. And when you sleep tonight, water will still be at work, healing, repairing, flowing. Every breath you take is part of a larger rhythm, an ancient pulse echoed in tides and rainfall, in rivers and hearts, in lullabies and thunderstorms. Even your dreams may float upon it. So drink slowly, breathe softly, breathe softly. You twanna peepide of peepenether, hins of anita wid tor blives ache, tolpas and of sturfingesats. That was an inso and bors torg. From in quick sproses water reverie pulls, it get tain to the vardy thing potbol. Let your body remember what it already knows. You are not separate from the earth. You are not separate from the oceans. You are not even separate from the stars that gave birth to water in the first place. You are water. You are memory. You are part of the story. And tonight, as you drift off, let yourself feel that truth. Let it cradle you like waves on a shore. Tomorrow, you'll rise again, refreshed, refilled, ready to flow forward just as water always does. But for now, be still, let go, and let the water inside you rest. Good night, gentle traveler, and sweet dreams. Earth's oceans are not just blue, they are ancient, alive, and always flowing forward. Close your eyes for a moment and imagine the sea. Not a single wave, but all of it. The whole blue, shimmering body that wraps around our planet like a soft, liquid blanket. Now imagine it not as something outside of time, but as time itself, flowing, rippling, remembering. Because the oceans are more than water. They are memory. They are movement. They are one of the oldest storytellers we have. Long before books, before language, before even trees and birds and breath. And breath, there were oceans, and they were alive in a way we still don't fully understand. Every drop you see in the sea today has been here for billions of years, shaped by starlight. An O-menning one, carried on comets, breathed out by volcanoes, washed into clouds, frozen in glaciers, buried in the ground, and risen again. It has flowed through trilobites and dinosaurs, through ammonites and mammoths through ancient fish and forgotten forests. It listened to the first thunder. It felt the heat of the first sunrise, and it cooled the crust of a still molten earth long before life arrived. It moved with the moon. It danced with gravity. It pulled on tides and slowly carved the continents. And now tonight, it sits beside you, lapping at distant shores, whispering the same rhythm it always has. If you could bottle a single cup of seawater, you would be holding a piece of deep time, not just in years, but in moments. Because the ocean remembers things we forget. It remembers the coolness of the Ice Age, the warm shallows where coral first bloomed, the shadows of sailing ships drifting silently through fog, the echoes of whale songs sung long before we knew to listen. It remembers the footprints of explorers, the prayers of castaways, the voices of sailors, lovers, and poets, each one leaving something behind in the waves. And somehow, it holds all of it. The storms, the silence, the beginnings and the endings. Even now, as you listen to this, water is moving through the oceans in deep underwater currents, like slow rivers hidden beneath the waves. They circle the globe over decades, even centuries, carrying heat, salt, nutrients, and memory. We call it the global conveyor belt, but it is really the breath of the planet. In and out, rising and sinking, steady and slow, and it is never still. No matter how calm the surface appears, the ocean is always flowing forward, not rushing, not hurrying, just moving like time does, soft, steady, inevitable. Some scientists say the ocean is where time touches Earth most deeply, because it's not frozen, it's not fixed, it shifts, it adapts, it weathers storms and remembers calm, much like us. And maybe that is why so many people feel something when they stand near it. A quiet pull, a softness behind the eyes, a stillness inside the chest, like hearing a song you've always known but could never quite name. It's because the ocean is not separate from us. We come from it. We carry its salt in our blood, its rhythms in our hearts, its chemistry in our cells. And one day, long from now, the ocean will still be here, flowing, but use the dough, changing, but telling stories in the language of waves. But for now, tonight, as you lie in the gentle quiet of this moment, know that you are floating on a planet made of memory, a world that is mostly water, a home that holds time in its hands. So, breathe slowly. Let the sound of distant waves lull you. Feel the current of life and time and water moving through you, because you are part of this story too. You always have been, and as the ocean keeps flowing forward, so will you. Sweet dreams, fellow traveler of the tides. Tomorrow, we flow again. May you drift tonight like a molecule in the tide, calm, timeless, and carried by the current. And now, dear friend, we've reached the quiet part of the journey. The tide has brought us here, softly, slowly, like a lullaby of science and wonder. And perhaps you're already feeling your eyelids grow heavy, your breathing gentler, your thoughts drifting. We've followed water from the silence of deep space to the waves kissing the shores of our own Earth. We've seen it dance between stars, freeze on comets, steam from volcanoes, and trickle into the very heart of life itself. And in all that movement, all that time, all that mystery, we found something beautiful, a planet that somehow got everything just right. Not too hot, not too cold. A little magnetic field here, a steady moon there, and suddenly, oceans, rivers, rain, from tears, life. You are made mostly of this ancient liquid, the same water that fell on the first forests, the same that carved canyons, the same that may have once trickled across the dusty face of Mars. And tonight, as you rest, it's still here, inside you, all around you, flowing through the quiet hum of life on a blue planet spinning through the dark. So as you lie back now, maybe tucked under a soft blanket, maybe with a cup of something warm nearby, I invite you to just let go. There's nothing you need to do, nothing to solve, nothing to worry about. You're already part of something ancient and vast and beautiful. You're floating. You're floating, not on a boat. The vaportos, and they don't have to, witty of Enian tifusing, Varmutaria pir eas, unand suav erfalav, not in a sea, firm, but in time, in story, in molecules that have known stars and storms and still come gently to rest in you. And just like those molecules, you too are carried by the current. So breathe in and breathe out, nice and slow. You are safe here. You are welcome here. You belong here, in this quiet corner of the cosmos. Now, before we fully say goodnight, I'd love to know, where are you listening from? Which part of the world are you gently falling asleep in tonight? Let me know in the comments below. It always warms my heart to see how far these stories ripple out, just like waves. And if this journey helped you slow down, brought you a moment of peace, or maybe just made you smile softly before sleep, I would be honored if you'd give the video a like and subscribe to the Snoozy Scientist. That support helps me keep crafting these calm little voyages for curious minds like yours. But most importantly, rest. Let your thoughts drift like mist. Let your dreams float like driftwood. Let your breath move like the tide, because you are part of this watery world, and it is part of you. So tonight, may you sleep like a molecule in the tide, calm, timeless, carried by the current, and when you wake, may you feel refreshed by the deep, ancient peace of water. From this little corner of the universe, I'm sending you a quiet wave. Good night. And sleep well, dream deeply. And remember, the story continues tomorrow. Good night, friend, and sweet dreams from a beautifully blue world.